the diagram looks like. Okay, the actual motion will start up here at the origin. This person runs out and ends up landing somewhere below the base, right? Somewhere below from where we started. Okay, this will be our origin up here. This is what the motion actually looks like. So out of our given problem, tell me some things that we can pick out and start adding to our list. Time. Okay, and time's going to equal 2.2 seconds. Okay. What it's initial velocity, but what type of initial velocity? X, yeah, horizontal, because it says he dives out horizontally. That means when he leaves the cliff, which is what we're concerned with, when he leaves the cliff, at that very instant, his only velocity is in the vertical direction. Okay, so that means v sub xi equals 4.0. If we know that when he leaves the cliff, he's only moving in the horizontal direction, what does that mean? V sub yi will have to equal, 0. Okay, so that's not going to be told to us in the problem a lot, but if we look and we see we have only horizontal initial velocity, we've got to be able to pick that out and put that into our list. Okay, so we've got to be able to recognize that. So what we want to know is how high was the cliff. So what variable should we be solving for? Yeah, y final, y sub f. Okay, that's going to be our question mark. Okay. So go ahead and look at your equation. If you have your equations written on another sheet of paper or like an index card, I think that's really helpful, but it's up to you.
Do the YF equals.
Let me look.
Do you need these?
Okay, so we use y sub f equals y sub I plus v sub yi.
You can use the.
We could use, okay. In our equation, we know we're solving for y sub f. What does y sub I equal? 0. Yeah, we assume that it's 0. We're going to start at the origin. So that's going to mean that y and x initially are both 0. Okay. V sub yi we know is also 0. Okay, so anything times 0 is 0. We're going to add plus 1/2. Acceleration, what's our vertical acceleration always? Yep, gravity negative 9.8 times time squared, which is 2.2 squared. What'd you get?
The final answer?
Mm-hmm.
Well, it was negative, but isn't it? Okay, 23%.
Are we in agreement here? Or are we not quite this far yet?
What'd you get? Yeah.
23.72. So why is it negative?
Because you're going down.
Yeah, we're landing below where we started, so it makes sense that our answer should be negative.
Is it mostly going to be negative?
If we're going off a cliff, yeah, or something. But the way we answer the question, since it technically asks how high the cliff is, we'll just make it positive and say the cliff is 23.72 meters high. Okay, so that's going to be something that I wouldn't count off for if you left it as a negative for that, because that's our final distance traveled. If you're technically answering the question, you just make it positive and say that it's 23.72 meters high. Does that make sense? Now we're going to solve for which variable?
X.
Yes, good. We're solving for x final. So we need to look on our horizontal equations.
XF equals VXIT.
Yep. Good. Good. All right, so x final. V sub xi we know is going to be this 4 meters per second because it's our initial horizontal velocity. So 4.0 times time, which they told us was 2.2.
8.8.
Yeah, good.
Nice.
Yep, it's meters because we're solving for a distance.
Oh.
So breaking down this velocity vector into components, our vector will look something like this. Maybe. And we know that it's 31 degrees Oh, east of north. I'm sorry, I drew it backwards. So 31 degrees goes here. And we want to find the components then of this triangle. Where does the 16.2 go here? If that's our actual velocity vector. Yeah, on the hypotenuse, good. Okay. So these are this is a velocity vector that we're breaking down, and we want to find the x and the y of this velocity vector, break it into components. So to find x, is x the adjacent side or the opposite side? It's the opposite side, which means we're going to use which trig function? Sine. Good. So I'm going to go ahead and abbreviate it, shorten it down here. 16.2 times sine of 31 is going to give us our x. 8.3. One decimal place is far enough. Okay, 8.3. So what would our units be if we're breaking down a velocity vector?
Meters per second.
Uh-huh. Good. Our components still have the same units. Okay, if we break down a velocity vector, we still get our result would still be a velocity vector component. All right? So to find y, we're going to take our hypotenuse times cosine of 31. You got 13.9. And what are the units then?
Meters per second.
Good. Okay, can we put a direction with these?
Yeah.
So what should they be for the x?
East.
East, and for the y? All right, good, very good. Now that we want to find how far it's traveled after a certain amount of time, we're going to go back to our first velocity equation that we learned. Velocity equals distance over time. Okay, I know it's been a while since we've done this. So let's work with our, we'll work with the north vector first since that's what it's asking for. Our velocity is 13.9 meters per second north. Our time is 5.31 hours. If we're going to plug this into our equation, can we do it as is?
Yeah. Well, you can.
We can find D.
We want to find D, but do hours and seconds match?
No.
Mm-mm. That won't work. Okay, so now we have to choose which one we want to convert.
Hours. Yeah.
Let's convert hours to seconds. Okay, so 3.1 hours to seconds, 5.31 hours.
60.
No.
Let's kill.
That's going from kilometers to hour to meters per second. So you're on the right track. So,
1 hour, 60 minutes.
yep, 1 hour equals 60 minutes.
And then 1 minute equals 60 seconds.
Exactly.
Times 60.
And that is 19,160.
Good. So that's how much time it takes us. So now instead of our 5.31, we want to use our time in seconds. That way our final answer can be in meters. Okay. If we wanted to convert our velocities to kilometers per hour, we could have. Okay. We could have kept our hours then and then had our final answer in kilometers. It doesn't really make a difference, but. All right, so now we're going to take our velocity as 13.9 equals distance over our time. And how do we solve for distance? Multiply. Good. Multiply. And we should get
265,712.4. Whoa.
Yeah. Okay, so that's how many meters we've traveled north in that time. Use the same time for this because it's the same number of hours. And we get, what Elizabeth, what'd you get?
158,662.8.
158.
62.
Great, thank you. What's the units? Uh-huh. Good, meters east. Essentially, what we just did is we broke it down to say if this person traveled for 5.31 hours in the north direction, they would have traveled, listen, if they would go north for 200 or for 5.31 hours at that speed, they would travel 256,000 miles or whatever we said, meters, yeah, thank you. 256,000 ... whatever meters. And then they would travel 100 and some thousand meters this way, whatever number we just came up with. I can't remember it off the top of my head. That would get them in the exact same place as our original resultant vector, okay, as going 31 degrees at this 16.2 meters per second velocity, okay?
So that would be like a plane flying, and that would be like a car driving.
Yeah, could be.
That's why it's so much faster.
Okay, so when we're dealing with launched projectiles, we're going to look here at just the very, very first step of these problems. Okay, and the first step is going to be to break down the initial velocity vector. So tell me what my initial velocity vector is here. 4.2 meters per second at what? At 40 degrees. So 4.2. That's going to be my hypotenuse. Okay, our initial given velocity is always going to be our hypotenuse. The 40 degrees, since it's with the horizontal, that means we make 40 degrees go right here next to the horizontal axes. Initial velocity that's given to you will be the hypotenuse of your triangle. Okay, and more often than not, these projectiles are launched at this angle right here from the horizontal. So it'll be the simplest one. Okay, more often than not. So now we're going to break down and try and find the sides of these triangle. This is a meters per second or a velocity vector. That means this initial velocity vector is being broken down. This side will be called v sub y I, and this will be called v sub x I. Okay, because we're breaking down our initial velocity vector. Okay, so instead of starting with only initial horizontal velocity, we're now going to have both components of that. So let's go ahead and solve for v sub y I. Is it the opposite or the adjacent side? It's the opposite. So we're going to use sine. So we're going to take 4.2 times sine of 40. What do you get?
No, I did X.
Oh, for the sine, I got 2.7.
Okay, 2.7. And what would be my units? Meters per second, because it's still a velocity. And so if we add that to our list, we would add it as v sub y I. So now our initial vertical velocity is no longer 0. Okay, for these ones that are launched at an angle. Okay, so let's solve for v sub xi now. 4.2 times cosine. Thank you. Meters per second. And if we added that to our list, we would call it v sub xi. Okay, so now once we've broken down this initial velocity vector, we are totally done with that 4.2 meters per second and the 40 degrees. Okay, don't let those numbers throw you off. Once we break them down, we're totally done with them. Okay, now we move on and solve the rest of the problem. Okay, we're done with that. All I wanted to show you here was the very first step. Okay, that's going to be the first step in a lot of these launch projectile problems, is breaking down that initial velocity vector. Any questions as to how we got here? Okay, let's try some. Football's kicked at an angle of 37 degrees to the horizontal with a velocity of 20 meters per second. Calculate the maximum height and the time of travel before the ball hits the ground again. we're going to find maximum height, and we're going to find the time. So I'm going to go ahead and draw our initial velocity vector right here. What should the hypotenuse here be?
20.
Yeah, good. 20 meters per second. And we're going to go ahead and put this component sides on. Okay. So what would be the name of this side if we're dealing with initial velocity?
Or V sub y.
V sub yi, our initial vertical, and this bottom side would be called good, V sub xy. Very good. Okay, let's go ahead and break them down and solve for these. So V sub xi would be 20 times what?
Sorry. No, XI is cosine.
Yes, exactly. Xi should be cosine because x is the adjacent side to this 37-degree angle. So 20 times cosine of 37. And what do we get? 16. Next one's wrong. Okay, so V sub yi, take 20 times sine of 37, and we get 12. Okay, so now we can go down and start our list here. So we're done with our diagram, we're done with the 20, and done with the 37. Okay, you don't have to cross them out in your problem. I just think it's a good way for you to not hopefully get confused here. So in our list, we have V sub xi and V sub yi. What other things do we know?
We know acceleration is negative 9.8.
Yep. We know x sub I is
0.
good.
And y sub I is 0.
Yep.
And you can.
Do you know X and Y are zero?
Those are stipulations that we gave when we turned out the equations. Okay, since we chose this right up here to be our origin, okay, this would be like the origin. That's going to be our starting point. Okay, so anything from there on is some distance from our starting point. Okay? So,
So xi and yi, if we choose an origin,
Yep.
So wait,
we're
are
always
we?
going to choose an origin.
yeah, and unless it tells you it starts 8 feet above the ground or whatever, you could always pick an origin and then say y sub f is negative 8. You know what I'm saying?
We're looking for y.
Okay, so we could always have it.
Yes.
Okay.
We're going to look for maximum height. So we're looking for the peak height, which is y sub f.
Okay. Could you use?
Okay, so since we're looking at this trajectory of this projectile at peak height, what does that mean the final vertical velocity would be at peak height? 0. Okay, at peak height, something reaches 0 velocity, right? So v sub y final, since we're looking at maximum height, is 0. Okay, so now let's take a look at our equation sheet and see which equation we could use to solve for y final.
The V sub Y squared.
Yeah. Yep. Let's use this. V sub yf squared equals v sub yi squared plus 2a y final minus y initial. Okay, do we understand why this final vertical velocity is 0? V sub yf? We understand why that's 0, or?
Yeah.
Kinda.
'cause it's like when you chuck the something up in the straight up in the
Exactly. It's just like when something reaches its peak height, we're going to 0 there. Okay, so 0 squared equals 12 squared plus 2 times negative 9.8 times y final. So we get negative 144 equals negative 4.9 y final.
Oh.
Divide it instead of times it.
I got
On which one?
2 times.
Oh, you're right. Thank you, thank you, thank you. I did this wrong. Thank you, Haley. It 2 times 9.8 is not 4.9, so that was my fault.
You did times a half.
I did times a half.
I
Yep.
got 29.4.
Yep.
What?
7.3.
So I need to divide by my negative 19.6. That's my fault.
Oh, whoa, whoa, whoa.
I accidentally took 1/2 times 9.8 instead of 2 times 9.8. So that was my fault.
Okay.
So now we're going to divide by negative 19.6.
7.3.
Divide by negative 19.6. And you get...
It's negative, does that matter?
We shouldn't get a negative because these two should become positive.
Wait, 2 times negative 9.8. What?
Oh, that one's
Negative? Why is that negative? It wasn't negative before.
Agreement here, 7.3.
Is that meters?
This was quite a trial to get here. Okay, yes, 7.3 meters.
Yeah.
All right,
But it's not there, that's all.
we're there. Okay, so now let's find the time it takes totally to travel through the air.
Wait, so that's not even what we were looking for?
Yeah.
We were okay.
We have 2 parts we had to look for. So I'm going to erase this work.
That's disgusting.
Do we have another little work time after
We can
this?
do.
Okay,
Oh,
so
guess what I just remembered?
listen. Okay, bring it back, bring it back. Okay, so now we want to find time. How do we solve for time? What equation should we use?
Ooh, let me think.
Send it that way.
Wait, do we need a vertical?
XF.
XF
We don't-
equals VXI.
Do we have-
times
We don't have
XF. We don't have XF.
I
I didn't know that.
VYF,
could use-
the VYF one.
It doesn't have time in it.
The YF.
No, the VYF equals VYI plus.
We want to try this one.
Yeah.
V sub YF. V sub Y.
Try this one.
I-
This is the right one.
It works.
Let's try this one.
Plus AG. That's it?
So what's VYF going to be?
0.
7.
Yeah.
VYI is going to be 12 plus negative 9.8 times time.
So,
Negative
Negative
9.8.
did you?
Oh.
So what's time equal?
1.2. Yeah.
1.2. Okay, so now let's look at this. Since we chose V sub YF to be 0, that means it's at what point in its path?
The top.
The top. So what do we do with our time?
Oh, you double it.
We multiply it by 2 because we want to know total time in the air. So we have to go to the top and back down. So we multiply that by 2 and we get
I'm not going to remember that.
I will.
2.4.
I need to multiply by 2. Because you're
What?
going.
Okay, we're going to try this one on our own. We want to find maximum height and the flight time. So we're solving for the 2 exact things that we solved it for in the last problem. Maximum height and flight time. Okay, that means time in the air. I'll go ahead and draw what our initial velocities should look like here. 4.5 at 66 degrees. So we want to solve for V sub yi and V sub xi. Okay?